Hello student. So today's session is on rotational motion. So I'll show you a comparative analysis between the linear motion and the rotational motion. So I believe that all of you have some good knowledge on the rotational or the linear motions. So I'll be showing a comparative analysis between the rotational and the linear motions. So linear motions, what are the examples of linear motions? Like a football is rolling on the floor, a cricket ball is rolling on the floor, right? So when those are going, we are saying that it's a translational motions. So during the translation means it's changing the positions, right? And also these balls are rotating with their own axis, right? So what actually rotation? Let me take one example, a classical example, like this is a globe. So this is an rotation, right? So this globe is rotating about its axis. So if you see about this axis, so this object is rotating about this axis. Okay. So what does it mean rotation? Rotation means this globe is not changing the positions, the coordinate positions. This part is not changing the position, right? So no translatory motion now. This globe is rotating. That means so theta angle, right? So the angular motion, rotation means the angular displacement is happening. So far you have learned about the linear displacement. So this is rotating means about an axis there is an angular displacement. So that is about the rotational motions. And for each rotation there is always an axis. So this is the axis. This is the axis, okay? Around this axis, if you see like an axis, it is rotating, okay? Now, one rotation means one complete rotation. How much angle covered? It's 360 degree. 360 degree. Now, so pure translational, and pure rotation and the both mix. Like football is, someone is having some free kick. So what happened? That the ball is translatory motion and also along with that, the ball is rotating, changing the positions, right? So it's a mix of translatory and the rotatory motions. Okay. Same for spin. When a bowler is spinning the ball, what happen? Both translatory and rotational motions happen at the same time because every time the ball is rotating about its own axis. Fine. So this is that day-to-day life we are seeing the object which is under rotation. Now let me show you a comparative analysis and also I will show you through Newton's second law the conservation of angular momentum, right? Okay, so I am going to the screen. I hope you can able to see the screen perfectly, right? Okay, that's great. Screen is ready. Fine. Now let me show you the combinations, right? So what is the combination? Like we know that mass. So this is linear and this is angular. So linear displacement is s, angular displacement is theta. Okay, linear velocity is v, angular it is omega. Then linear motion, this is acceleration and here acceleration will be change, angular acceleration. Okay, so this is the linear, this is the mass and angular motion we are seeing the I, the moment of inertia, which is equivalent to mass. Okay, so these are the four things. Now, and one more thing is the forces. The linear force is F, angular force is tau. So these are all vector quantity like this. Okay, work done in linear motion, work is equal to Fs cos theta, and here work is equal to tau theta. So force equivalent to tau, S equivalent to theta. Theta is the angular displacement. So if you go like this, it will help you to take the chapter to understand the rotational motion very easily. Because linear motion already you have good idea, right? Now, what are the the equation of motions? Now I will be showing you the the kinematics of rotational motions. Okay, let me remove this part. So linear is v is equal to u plus at. So rotation it will be omega t is equal to plus alpha t, right? Next, so I think you can able to see the things very clearly, right? Okay. Next is v square is equal to e square plus 2as, here the final angular velocity is equal to initial angular velocity omega square to alpha theta, like this. Okay. Next is the s is equal to ut plus half a t square. Here it will be in angular motion theta is equal to omega 0 t plus half alpha t square. So these are the equation of motions in angular, and this will be for the linear, right? So now next is the so let me write one more time. So omega t is equal to plus alpha t to alpha theta. ठीक है? Right. Now next is force. Next is the linear momentum is mass into velocity. So angular momentum will be angular mass into angular velocity I omega, right? Now angular momentum symbol is L is equal to r cross p, or you can say rp sin theta. So angular momentum is an vector quantity, p is the linear momentum, r is the position vector, rp sin theta. Now you know that there is an important relation. That's called theta. Theta is the displacement. So theta and omega. So there is a relation v and omega. What is the relation? V is equal to omega r. V is equal to omega